All right, the second example today, differentiating a quotient. Okay, f of x equals something about x divided by something about x. So function of x over a function of x. And what we're going to use here is called the quotient rule. And it also looks very complicated, but again, if you just focus, we have a top function and a bottom function. It starts off with the bottom function times the derivative of the top function. Then we subtract, it is a minus sign there, then the top function times the derivative of the bottom function, and all that goes over the bottom function raised to the second power. Okay, that is the quotient rule. The mnemonic device I've heard in my years of being a calculus teacher, low d high minus high d low over the square of what's below. It's kind of a little poem.
Nice.
There's also one that goes to the tune of row, row, row your boat, but low, low, low d high minus high d low, that is what goes on top, square what's below, something like that. I don't know.
Nice.
But that low, 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 it just people like write three lows there. So but just know it's one. But I like the poem better. Low d high minus high d low over the square of what's below. Low bottom d high derivative of top minus high top d low derivative of bottom all over the square of what's below.
Will we be able to use like a formula sheet with that on it?
Through practice you're going to know it.
Okay.
I mean, I expect you to know it.
Okay.
But you have this yellow sheet here in front of you. Use that as a reference when you need to in homework, but learn it.
Okay.
Know it, because it's used a lot. And it's something you don't have to always refer back to something. So get to know it. Learn your little poem there.
Yeah.
Right. Most people do it wrong. They do this backwards. They do high d low minus low d high. But it always starts bottom derivative of top minus top derivative of bottom. And because it is minus, it does matter. Okay, it has to be that low d high first. So, if we take a look at f of x, high is 3 plus x squared, low is 3 minus x squared, and we're differentiating. Now, this does not have some algebraic technique to simplify it down to a simpler form. All right, the quotient rule typically cannot be avoided. If you have to use it, you have to use it. All right, unlike the product rule, which as long as you're dealing with polynomial functions, there's always that capacity to multiply the functions together. For this one, product rule, my low function is 3 minus x squared. My high function is 3 plus x squared. All right, so if I apply the quotient rule, okay, basically I create this structure here. Low d high, high d low, square what's below. So, if we start with low d high, low is 3 minus x squared. D high is derivative of the top. The derivative of 3 being a constant is 0. The derivative of x squared is just 2x. The functions on top and bottom are just polynomial functions, so differentiating them is just the power rule for each one. So again, the derivative of the top, d high in this case, is just 2x. Then I do high d low, that's going to be the top exactly as it's written. And then for d low, the derivative of 3 being a constant is 0. The derivative of negative x squared using the power rule is going to be negative 2x to the first. Over the square of what's below, so we take whatever the bottom is, in this case 3 minus x squared, and we square it. That's the calculus of the problem. Okay, applying the quotient rule is the calculus part of the problem. What's left then is the algebra part of the problem, which is to simplify as much as possible. For me, using the quotient rule, I'm going to leave the bottom as 3 minus x squared squared. I'm not going to square that out. If we're going into second, third, fourth derivatives, this is a better structure. All right, so just keeping it as 3 minus x squared squared is better. As far as simplifying the top is concerned, the one place that people tend to mess up is the fact there's a minus sign here, and there's usually multiple terms here. Okay, be careful when you do your algebra that when you multiply this out, that minus is still affecting everything you get in this product. So let me just focus on that part of it. Minus sign here. If I distribute this negative 2x through, I'm going to get negative 6x minus 2x cubed. That minus sign is affecting both pieces of that product, not just the first piece. So make sure that as you multiply this out, you keep it in parentheses until you account for that minus sign. This first product isn't that big of a deal. 2x times 3 is 6x. 2x times negative x squared is negative 2x cubed. There's a plus sign officially in front of that, so those signs are what they should be. All that goes over 3 minus x squared squared. Again, I don't mess with that usually. So now if I distribute this minus sign through, and add like terms in the process, I think we can handle that being in calculus, right? 6x, it'll be plus 6x, right? Minus minus is plus. So 6x plus 6x is 12x. Negative 2x cubed, it'll be plus 2x cubed. What's negative 2x cubed plus 2x cubed?
0.
0, they cancel. All over 3 minus x squared squared. And that is the derivative simplest form. Right? The calculus of the problem, again, is going from the function using the quotient rule to get the derivative. Once you get the derivative, at that point it's just an advanced algebra problem. Okay, so just take your time going through the algebra problem. Again, it's always minus, and there's usually multiple terms for high, D, low. Usually multiple terms happening there. So minus multiple terms, make sure that minus sign distributes. That's the most common place people mess up, right there. All right, and again, it's a matter of practice. As Tyler asked, do we have to memorize this stuff? Through practice, you'll memorize this stuff. It's not like you're going to have to sit down each night and do this little poem in your head to memorize it. Just by practicing it, using it, getting to the point where you're getting accustomed to it, you won't have to refer to that sheet as much. You'll have it in your brain.